10 fingers and 10 toes. And that's probably why our number system is based on 10. Aside from this, there's nothing special about 10. Our number system might have been based on some other number, 12 or 8, for example. The ancient Mayan Indians who live in Central America used a system based on 20. And most computers, like this one, work on a number system based on 2. Anyhow, working with 10 is easy because we've based our money on 10, what we call a decimal currency. Decimal is a Latin word for 10. That's good news. And another plus is that the metric system of measurement, which is used in every major country but one, is also based on the number 10. The bad news is there's one holdout, the USA. But we can still use 10s to help us with all sorts of calculations that help us answer that all-important question. In math, how much? As you shall see, let's watch our teacher begin to show us how we use our money system.
This is a situation that we have found ourselves in nearly every day. We've arrived at a store with $30 in our pocket, let's say, and we need to purchase some items. The question is, do I have enough money with me to buy the items that I need to purchase? Well, what this brings up is a common, everyday mathematics situation. How do we know whether we have enough money? Well, what we're going to need to do is estimate the cost of each item, then add those costs together and compare that to the $30 that we have to see if we have enough money to buy the items. Well, let's look at these items. This particular item was $14.98, or approximately $15. This item was $8.98, or about $9. And this final item was $2.98, which is an estimate of about $3. Well, let's add our estimates together. $15 plus $9 is $24, plus the $3 is $27. So that 27 being less than 30 tells us that we should have enough money to buy these items. Well, now actually what have we done? Well, first we estimated the cost of each item, and then second, we added those estimates together. And third, once we got that approximate total, we compared it to how much money we had. Well, let's use the calculator to find the exact total, and this will tell us whether or not we've made a good estimate. Let's turn the calculator on and go back through this item by item. This first item, the most expensive one, was $14.98. To that, we're going to add the second item, which was exactly $8.98. And the third item was $2.98. And our total is exactly $26.94. So the calculator has told us that the estimate that we made of $27 was a very good estimate and that we have enough money to purchase the items.
I find that students estimating is something that can help students a whole lot. If you have a big number that you have to add together with another big number, sometimes it's really easy to round it off and add that together. And where you're working with, you know, if you have 597 and you want to add 398, you can add 600 and 400 quickly and get 1,000. And it's good to estimate. It can save time. It can save a lot of headaches. That's what you do with real life math, is you estimate things.
We see numbers in many different forms. One of the most common forms is to see numbers written as decimals. For this reason, it's important that we understand what decimals are and how we compare them. In this segment, we're going to talk about comparing decimals. We need to remember that decimals are fractions with special denominators. We also want to remember that decimals are just numbers with labels, and we treat them as we would treat any numbers with labels. For example, what if I asked you to compare 2 feet and 27 inches? Well, at first we pause, And then the first thing we would do is we would change that 2 feet to 24 inches and compare them when they have the same unit. And we know that 27 inches is more than 24 inches. And that helps us to understand the comparison between those two numbers. Well, we're going to treat decimals in the same way, and we're going to use this grid to help us do that. We see that we have a grid that's 10 units in this direction and 10 units in this direction, or 10 times 10. This unit is divided up into 100 equal squares, which makes it real nice because it helps us write the decimals as they are given. You can see that if I pick this up, that I actually have a segment here that is 10 of those squares. So it's 10 out of the 100 squares that are here. As a fraction, that's 10 over 100. We know as a decimal, that's decimal point followed by 10, which we read as 10 hundredths. I could take that same strip and turn it over, and we could see that it represents one of the 10 columns that form this same grid. And so what I have covered here is 1/10 of my grid, and that's what this represents. But I used the same strip that was 10 hundredths. It's also 1/10. What that tells us is that 1/10 and 10 hundredths represent the same number, two different names for the same amount of this board that's covered. So those are equal decimals. Well, let's take another strip that is 10 hundredths. So we really have 10 hundredths, now 10 more, or 20 hundredths of the grid is covered. In the same way, we knew that this was 1/10, this also is 1/10, and so this also represents 2/10 of the entire grid that's covered. Well, what we've stated here is that 2/10 and 20 hundredths are equal decimals. Now, let's compare decimals that are not the same. Let's take away these 10 units, and let's replace them with these 3 units. And now, what portion of my grid is covered? Well, there's these 10 hundredths, 11, 12, 13 hundredths. Now, 13 hundredths compared to 20 hundredths. Which one covers more of the grid? Well, clearly, 20 hundredths. Now, why is that so easy to tell? Well, because they were the same label. When we are comparing decimals, compare hundredths to hundredths. And then it's the same as the concept that we used when we talked about comparing 2 feet to 27 inches. It became much easier when we compared 24 inches to 27 inches. Numbers that meant the same thing, and very easily we could tell that 27 was more than 24. So, decimals work the same way. Compare hundredths to hundredths and tenths to tenths, and it's a very easy process. The next time that you have decimals to compare, make sure that you do that. Make sure that you're comparing them with the same label.
So sometimes there is waitress that she's not very good in computing it or what. Table, she had the table of multiplication, and she had this kind of tax table that she can really read on. And she just total the amount of the food, and she look at the range about how much is the total tax right away. But like me, I have sometimes she multiply by herself. I do figure it by myself also, you know.
In this segment, we're going to talk about what sales tax is and how we use it to calculate the total amount that we have to pay.
There's a shirt here, Vince, that illustrates a nice situation I faced just recently. Price of the shirt was $32.99 plus a 5% sales tax. I wondered if I had enough to pay for it when I got to the counter. I only had $35, so my question was $32.99, $33 plus 5% sales tax. Will $35 be enough?
Well, let's go over to the grid and let's explain what sales tax means. And let's use 5% as an example, understanding that whether it's 5% or 6% or 4%, we're still going to do the same kind of problem.
We can think of percent as based on 100, and a dollar is a good example. Here's a dollar's worth of pennies. So if we were to find 5% of this, it would be 5 cents. 5% of a dollar plus 5 cents for sales tax would cover a dollar's sale item. If I bought something for a dollar and only had a 4% sales tax, well, then I'd pay the dollar plus 4 cents for the sales tax. So sales tax really is what percent of a dollar? 5% sales tax, 5 cents on a dollar.
And the reason for that is percent is based on 100. And our money system is based on 100. There are 100 cents in a dollar. So whenever we see the sales tax is 5% as an example, that means for every dollar we spend, we must pay an additional 5 cents. Well, let's use the grid to explain that just one step further. We can see that there are 10 along this road and 10 along this route, and so that gives us a 10 by 10 square, which means there are 100 different squares here. And we could put a penny in every one of these, and it would represent 100 pennies, which is a dollar. Well, it always says plus tax, and it is based on a dollar, based on 100, so these 5 squares could represent the 5% sales tax. It's plus 5 more. Just like we could put a penny on each one, if this represents a dollar, that 5% represents these 5 cents more. And that's what sales tax is. So if we have $1, we're going to have 5 more cents that we have to pay.
One way I like to think about it is if I make a purchase of, say, $2 or $3, let's say $2, I'm going to pay 5% for each dollar I spend. So if a $2 purchase, 5 plus 5, 10 cents. For a $3 purchase, 5 and 5 and 5 more, I'd pay 15 cents in sales tax.
Right. When the numbers are small, when it's $2 or $3, we can just add those together. And we know that when we repeat addition, it's multiplication. And so when we have a problem like we looked at before where it was $33, doesn't make sense to add 5 33 times. We multiply. So let's go over and use a tool now, the calculator, to show how easy it is to find sales tax.
First thing we need to do is figure out just how much the sales tax is, and that's just a matter of putting in the price of the shirt times, and then the percent part, 5%, and there's the sales tax, $1.65.
And that was one of the things that we wanted to accomplish. That's how we find sales tax. We take the price and we multiply it by the percent sales tax.
Now we've got to get the addition part. We'll add the sales tax to the price of the shirt, $33, plus that $1.65 we figured out. Here's the total price I'd have to pay at the checkout counter, $34.65. So if I had $35, I have enough to buy this shirt.
And that's the second part of the problem. And it always says plus tax, which means at some point we are going to add.
Plus.
So we have seen that sales tax is nothing more than a certain number of cents for each dollar that we spend. 5% means that for each dollar, we will spend an additional 5 cents. That's what the sales tax means. We also learned that we can calculate the sales tax by taking the price of an item and multiplying it by that percent. As we did before, we multiplied 33 times 5% to find out what the sales tax was. And that led us to the final piece, which we added the amount of sales tax to the price of the item, which gave us our total cost. Now, we have seen that on $1, a 5% sales tax is only 5 cents, or a nickel. It doesn't seem like much. But what happens if the cost of our item is large, like a $2,000 car? What would the sales tax be at 5% on a $2,000 item?
Being a waitress is a great way to make a good living. The base pay is only $2.20 an hour, so you have to know how to calculate your tip. In this establishment, we're allowed to add 15% gratuity onto all of our checks. In order to do this, though, you have to know what 15% is, which is 0.15. For instance, if the check was $100, your tip, which you're allowed to add on, is 15%. You take $100 times 0.15. You can do this on paper, or you can punch it into the calculator. You can take this profession anywhere in the country, maybe anywhere in the world. $100 maybe was too easy. Okay, say your check was $30. 15% of that would be $4.50. You can do it on paper or on a calculator. You take 30 point times 0.15 will give you $4.50. And if your sales are $1,000 that night, that's $150 in your pocket. Not bad, huh?
We've seen how to work with tens. Now we'll see how this skill and other math skills that we've learned can answer one of the biggest questions in mathematics. How much?
the real world, addition, subtraction, and estimation are used quite a bit. In fact, we probably use them so much we don't even think about it. My purpose today is to give you a real-world example of the use of estimation, addition, and subtraction in a problem situation that you and I have faced many times. Here's the situation. I need to purchase some shelving. I go to the hardware store and find that there are 3 lengths of shelf that I need. This length costs $1.29. A length about that size is $1.79, and the largest length is $2.89. The first thing I'm going to do is estimate. Because I don't know about you, but I find it quite difficult to add up numbers like $1.29 and $1.79 in my head. So we're going to round off. We're going to estimate the $1.29 shelf to be $1. The $1.79 shelf will round off to $2. And the shelf that costs $2.89 will make that $3. So we've estimated to have numbers that are easier to use. Now, what are we going to do with these numbers? We're going to add them. Why? Because I want to know how much, approximately, these 3 shelves are going to cost. Remember, the first shelf we estimated to be $1, the second $2, and the third shelf $3. So adding up 1 plus 2, which is $3, plus 3 more is $6. So I now know that my total cost of the 3 shelves is $6. If I have $10 in my wallet, I know that I have more than enough money to purchase the shelves. But now I need to subtract. Why subtract? I want to make sure I get the right change. 10, the amount of money I have in my wallet, minus 6, the total cost of the shelves, is $4. So I know that when I get to the cash register, I can expect about $4 change. You know, it's possible that the cashier makes a mistake. But if I get much more or much less than $4, I will know that the mistake has been made and can see that things are corrected.
Shopping for a family isn't easy, particularly if you want to save money. A way you can make this problem a little simpler is to make up a shopping list ahead of time and stick to it. And also, don't go grocery shopping when you're hungry.
We handle a lot of money here, sometimes up to $1,000, $1,500 a day, which we use a lot of math. We've got special rates for chairs and umbrellas. We get $15 a day. Sometimes if people want to use it just for a half a day, we'll give it to them for, you know, basically probably 60% off, you know, $6, $7, you know, it varies. It all depends on how long they're going to be out here. Also use math and making change for people. Sometimes I use a calculator for, you know, if I got to make, at the end of the day, I've got these sheets, so I've got to do all my adding up on all these sheets and turn these in at the end of the day. I also have room charges that we do, which we've got to make up total, so we do a lot of adding with that. All the figures at the end of the day, you add up $1,000, $1,500 a day. That's a lot of math, so calculator does come in handy for that.
This is a situation that we find ourselves in almost every day. We've arrived at a store or a restaurant, and we want to know, do we have enough money to cover whatever the charge might be? Do we need to know exactly how much money it costs to buy all the food or buy whatever we're buying? Well, the answer to that is no. We just need to have a good, useful guess for how much money to have with us. Similar to this kind of question, if I was to ask you which one of these cards had more dots on them, I'm sure that very quickly you recognized that this was the correct answer to that. Well, did you count the number of dots exactly? Well, the answer to that is no, you didn't count them. You can very quickly recognize and make a good guess as to which one had more dots on it. That useful guess is called an estimate. We make useful guesses, estimates, all the time. As a matter of fact, we're surrounded with it. When we pull into the service station and we ask to have our oil checked, the person goes in, pulls out the dipstick, and there's no way for them to know exactly how much oil we have. But we very often hear them say, you know, the next time you come in, you're going to need about a quart of oil. About 1 quart. That's an example of an estimate. In the fall, the leaves on this tree are going to turn colors, and then the leaves are going to fall to the ground. Now, we don't need to know exactly how many leaves are on our lawn. More than likely, though, we are going to need to know how long is it going to take us to get them off of our lawn. And so we'll make an estimate. We won't say something like, well, it'll take us 1 hour and 23 minutes to rake up all these leaves. We're more than likely to say, Oh, between an hour and 2 hours, and I'll be done with that job. Estimation, something that we do all the time. We often say, well, it's nearly 30 miles from this town to the next, or it's about 15 minutes until the train arrives. How many times have you reached into your pocket and pulled out some change and said, well, let's see, that's less than $1. That's an example of an estimate. Estimation is a very important mathematical skill. Why? Well, you may now recognize that almost every number that you use is an estimate of one form or another. It's rare for us to have to use an exact amount of anything. There's one more point we need to make about estimation, and that's the point about accuracy. If we were to look at the United States from the East Coast to the West Coast, we know that it's about 3,000 miles. Now, if we estimated it to be 3,100 miles or 2,900 miles, those would be good estimates, even though we were maybe off by 100 miles. If we, on the other hand, wanted to find out how far it was across town, and we made an estimate that was off by 100 miles, we would have a very bad error. The point here is this. When you're making an estimate, it only becomes a good estimate when you're in the right situation.
Look at that one over there, what you put out. Isn't it great? This cow has produced 35 pounds already. And, but with no doubt that she'll go at least 40 pounds, which is 5 gallons of milk. Go, girl. Go. Go, girl. Come on, girl. Go.
Have you ever found yourself in this situation? Trying to get the water out of the pool and wondering, why does this weigh so much? In this segment, Art and I are going to talk about a pool like we've just seen and the water that's in that pool. And we're going to look at it in 3 different ways.
One of the obvious ways we'll look at it is just how much the water would weigh that would fill this pool.
A second way we're going to look at it is the capacity. That is, how many gallons will it take to fill the pool? And the third way that we're going to look at it is by volume. That is, how much space will that water take up? So we're going to look at weight, capacity, and volume.
One of the ways to think about volume is to use this unit of measure. It's a cubic foot. I guess it's kind of obvious why it's a cubic foot. It's shaped like a cube, and it's a foot wide, a foot long, and it's a foot high. So we have 1 times 1 times 1, 1 cubic foot. So this is one unit of measuring the water, a unit of volume called a cubic foot.
Right. I have what is obviously a gallon container, and this is a measurement of capacity, as we've said before. We know that a gallon really contains 4 quarts. Those are 2 different sizes that we measure capacity. Let's take this gallon of water and let's pour it into this cubic foot and see if we can fill it up. I'll tell you, Art, this gallon of water is pretty heavy. As a matter of fact, a gallon of water will weigh about 8 pounds, just a little more than 8 pounds.
Now that's not even be close to filling this cubic foot, so this is going to weigh a lot more than just 8 pounds.
Well, it's empty now. If it comes to about here, we're going to find out that if we continued this process, it would take about 7.5 gallons to fill a cubic foot.
So we could think of a cubic foot of water another way, using capacity 7.5 gallons. If we put those 2 together, then we can get some information about the weight of the water. So if we had 7.5 gallons, and a little more than 8 of them fit in here, then that's about 60 pounds for just one of these cubes. And I don't think that would even begin to fill the bottom here. It wouldn't even cover the bottom, 1 cubic foot's worth.
No, I don't think so. I think we'd be safe to say that it probably is going to take about 20 or 25 cubic feet to begin to fill that pool.
And if you talk about that many cubic feet, there's another unit of volume that we can discuss. We have a cubic yard.
Right. And this is called a cubic yard for the same reason that we called a cubic foot a cubic foot. This red cubic foot down here is 1 foot wide, 1 foot long, and 1 foot high. As you said before, that makes it a cubic foot. Well, the cubic yard is 1 yard wide, 1 yard long, and 1 yard high. So it's a cubic yard.
You could also think of it in terms of feet. If it's 3 feet wide and 3 feet long and 3 feet high, we can figure out how many cubic feet.
3 times 3 is 9.
And then 3 feet high makes
27.
So there's one. It would take 27 of these to fill this cube. So we could think of a cube as 27 cubic feet, 1 cubic yard.
1 cubic yard is 27 cubic feet. Well, if we had 20 cubic feet that were going to go into that pool, and each cubic foot weighed 60 pounds, we're looking at
1,200 pounds. That's more than half a ton, for heaven's sakes. No wonder this thing was so heavy.
If it was 20, if we looked over here, that would probably fill water up to about here on this cubic yard. 1,200 pounds. That's a lot of weight. Well, we've now connected weight and capacity and volume by using the water. Each of these weighed about 8 pounds. We found out that 7.5 of them were in here, and in that way we got an idea as to how much it would actually weigh to fill that pool. Now, why is this important? Where do we use weight and capacity and volume? Well, we buy things that weigh a certain number of pounds all the time. For example, we buy dog food by the pound, we buy nails by the pound. We use capacity when we buy gallons of milk or gallons of paint. And if you've ever purchased concrete, you buy that by the cubic yard. You buy it by volume. So you see, weight, capacity, and volume are things that we use on a regular basis.
So I think that you can see, being able to work with tens helps us answer that question, how much? And more important, it helps us keep our money straight. And that's the bottom line.
You've been watching Math Basics, a series designed to help you improve your math skills. To get the most out of Math Basics, you need to do 2 things. First, call the number on your screen to find whether there's a Math Basics enrollment program in your area. Enrolling in Math Basics will help you find out what math skills you need to study most. You'll also get information on where you can go for help with your math questions. When you call, be sure to order your Math Basics workbook. The workbook gives you the chance to practice the math skills you need to solve everyday problems. Call today and find out how you can study at home with Math Basics. Call toll-free 1-800-354-9067. Visa and MasterCard accepted.